Are you a YouTube content creator? Do you upload your music to YouTube? If so, you have to manage how loud the audio in your videos should be. Will YouTube reduce your music because it's too loud? A close look at the volume information in YouTube Stats for Nerds will help you achieve the right levels for your audio. We'll look at YouTube's target or reference level, normalized volume, and content loudness. We'll also learn how to calculate the LUFS volume for any video on the platform, and even how to predict what volume YouTube will play your video's audio before you upload your video. So, grab your calculator, and let's get nerdy with YouTube's Stats for Nerds volume data. Play any YouTube video. Here, I'm using my song, Beetlejuice Blues. Right-click on the video and select Stats for Nerds. To understand the audio level for the video, what we are interested in is the line that says, volume/normalized. For the Beetlejuice Blues music video, we see the values 100%/88%, content loudness 1.1 dB. What do these numbers mean, and how can we use them in our music and video productions? The first number is the value of the YouTube volume slider under the little speaker icon at the bottom of the video player, shown as a percentage value. If we drag the slider left, the volume decreases, and the first number declines to show the reduced volume. So, this first number simply shows the volume level of the video player. It has nothing to do with the inherent volume of the audio track itself. To make things simple and consistent in the following discussion, make sure to set the video player volume at 100%. Skipping the second number for now, the third number, called content loudness, does indeed derive from the volume of the audio you set into your video. It's a relative value showing how much your audio loudness deviates from YouTube's preferred loudness, or reference level, in decibel dB units. As you may have heard, YouTube's reference level is -14 LUFS, the maximum integrated LUFS value allowed during playback. For music, this is a fairly conservative loudness level, which allows good levels of dynamic range. Please refer to other resources to fully understand LUFS values, and how to achieve appropriate volume levels using your audio-video editing software. I don't explain it here other than to say that, like content loudness, LUFS are also measured in decibel dB units, and louder audio has a less negative LUFS value, closer to 0 on this graph. For example, -10 LUFS is louder than -14 LUFS. We are using integrated LUFS values here. Also, while YouTube's reference level is -14 LUFS, I am not advocating that you necessarily shoot for that loudness. The appropriate loudness level for your songs is more complex than simply aiming for a fixed LUFS target. Okay, back to content loudness. When the content loudness is a positive value, the audio is louder than the YouTube reference level. When negative, the audio is quieter than the reference level. Video A has a +8 dB content loudness, because it is louder than the YouTube reference level. Video B has a -5 dB content loudness, because its volume is under the reference level. We can easily calculate the corresponding LUFS values for these two videos. Video A is +8 dB louder than -14 LUFS, so the audio for video A must be -6 LUFS, that is, -14 + 8 is equal to -6. Video B is -5 dB softer than -14 LUFS, so the audio for video B must be -19 LUFS. This is useful. We can now calculate the loudness level in terms of LUFS dB units for the audio in any YouTube video. For Beetlejuice Blues, the content loudness is 1.1 dB. This positive value means that the song is slightly louder than YouTube's reference level of -14 LUFS. Indeed, when mastering Beetlejuice Blues, I set it at -12.9 LUFS. So, compared to the -14 LUFS reference, the song is 1.1 dB louder. Doing the easy arithmetic, -14 LUFS plus 1.1 dB equals -12.9 LUFS. What about another song? At the time of this writing, Beyoncé's Cowboy Carter album is hot off the mastering console. The single, Texas Hold'em, shows a content loudness of 6.1 dB, and is therefore 6.1 dB louder than YouTube's reference. Using the same arithmetic, it was apparently mastered at -7.9 LUFS, that is, -14, plus 6.1, equals -7.9. Interesting. That's quite a bit louder than the reference level. In fact, content loudness values on YouTube vary widely. I searched through YouTube music videos to find videos from very loud to very quiet. Here's a representative list of music videos, sorted from loud to soft, showing the wide range of content loudness values. Also shown are the calculated LUFS values at which these songs were apparently mastered. Links to the videos are provided in the video description. Note the content loudness values ranging widely from a loud 10.8 dB over the reference level, down to a quiet -18.4 dB below. The wide range of content loudness values shows that mastering engineers have differing opinions and purposes regarding appropriate volume levels, irrespective of what YouTube expects. Reasons for this include genre. It may make sense that more aggressive music, like metal and EDM, is mastered louder than more mellow music, like new age or classical music. Media. CDs are typically mastered louder than streaming media. So if a song is ripped from a CD and directly uploaded to YouTube, it likely has a relatively higher content loudness. Dynamics. Louder masters typically have more compressed dynamic range, which may enhance the song's emotional impact. Competition. During the time of the volume wars, loudness levels were pushed way up, as exemplified by the Metallica song at the top of the list. Knowledge and skill. The mastering engineer may simply not understand LUFS, or how to achieve a particular integrated LUFS level. Artist/client preference. The artist or client may simply prefer a louder or quieter recording, in spite of contrary advice. But, again, YouTube's reference level is -14 LUFS. If you've gotten this far, you must be asking, what happens if my audio misses the target? And, what about that second number? If your audio is quieter than -14 LUFS, YouTube does nothing. YouTube assumes this is intentional and leaves the volume at the level you set. Audio no louder than -14 LUFS certainly doesn't risk blasting out anyone's eardrums. But, if your audio is louder than -14 LUFS, YouTube will reduce the volume. That's what the second number shows. The second number is the YouTube normalized volume in percentage terms. Normalized means YouTube reduced the volume to some percentage less than 100% of the original volume. In this example, video A would be reduced by -8 dB, from 100% to a normalized volume of 40%. In Stats for Nerds, it would appear like this. Notice that all the songs in the list with a negative content loudness have a normalized volume of 100%. Because these songs are quieter than the target, YouTube uses the full, 100% volume, as you delivered it. But all the songs with a positive content loudness have a normalized volume below 100%, showing that YouTube has reduced the volume of these too loud videos. For Beyoncé's song, its content loudness is 6.1 dB too loud, at least, too loud for YouTube. Thus, YouTube has reduced the normalized volume down to 50% of the original. Beetlejuice Blues is 1.1 dB over the reference level, so it is normalized to 88%. The hottest song on the list, Metallica's My Apocalypse, is reduced way down to 29% of its original volume. The second normalized volume value also responds to a change of the YouTube video player's volume slider. In other words, the second number is relative to the first. So if Texas Hold'em is played back at 80% volume, its actual content is being heard at a normalized 40%, which is the same 50% reduction as before. To repeat, the slider volume is irrelevant to YouTube's volume normalization of your video. Keep the slider volume at 100% to see the values used in this video. A difference of +6 dB corresponds to about a doubling of a sound wave's amplitude. So, to reduce audio that is 6 dB too loud, a YouTube volume reduction of -6 dB is required, which corresponds to about a half, or 50%, normalized volume. Nerd note. +6.02 dB corresponds to a doubling of amplitude or voltage, which are objectively measurable physical phenomena. It is sometimes stated that plus 6 dB is twice the volume or loudness. But the terms volume and loudness relate to the human perception of sound, which is subjective. For this reason, plus 6 dB is not necessarily perceived as twice as loud. Nonetheless, YouTube uses the objectively measurable plus 6 dB doubling yardstick. The term normalized volume must be understood within this context. This relationship between content loudness and normalized volume can be generalized by the formula. Normalized volume equals 10 to the power of the decibel reduction divided by 20. In this formula, dB represents the content loudness normalization amount. That is, if the content loudness is plus 6 dB, the volume will be reduced, or normalized, by minus 6 dB. If we plug minus 6 dB into the formula, we get normalized volume equals 10 to the power of minus 6 divided by 20 equals 0.50, or 50%. As just seen for the Beyoncé video. For example, using the Maroon 5 song with a content loudness of plus 2.7 dB, YouTube will reduce it by minus 2.7 dB. So, enter minus 2.7 dB into the formula. Normalized volume equals 10 to the power of minus 2.7 divided by 20 equals 0.73, or 73%. Which agrees with YouTube's normalized volume for the song shown in the list. Doing the same for She's on Fire, YouTube will reduce it by minus 7.6 dB. Normalized volume equals 10 to the power of minus 7.6 divided by 20 equals 0.417, or 42%. So, now we understand, and know how to calculate, all three values shown in the YouTube stats for Nerd's volume line. And, when compared against the YouTube reference level of minus 14 LUFS, we also know how to calculate the LUFS level for the audio in any video on the platform. How can we use this knowledge to help us choose a mastering level for our songs? Let's say you have mastered your audio to be minus 9.5 LUFS. What normalized volume would YouTube use? Well, minus 9.5 LUFS is 4.5 dB louder than YouTube's minus 14 LUFS preferred loudness. So, your video's content loudness will be plus 4.5 dB, and YouTube will therefore reduce it by minus 4.5 dB. Entering minus 4.5 in the formula, we get normalized volume equals 10 to the power of minus 4.5 divided by 20 equals 0.596, or 60%. So, when you deliver your video with its audio at minus 9.5 LUFS, YouTube will reduce its volume down to 60% of your original volume, so that it sounds like minus 14 LUFS. The stats for Nerd's volume data line would look like this. You may decide that a volume cut to 60% is unacceptable, and therefore remaster your song to a lower LUFS level. Or, you may like the way your song sounds even at the lower volume. That's your decision. But at least now you know beforehand what the YouTube loudness penalty will be. The minus 14 LUFS reference level is for YouTube's video platform. But every streaming platform has its own way of dealing with loudness, making the mastering process even more difficult and subjective. Some use different reference levels. Some will raise the level of two quiet songs. And the platforms have been known to change their loudness policies over time too. For example, the separate, subscription-based YouTube Music service has a different reference level. The stats for Nerds within the YouTube Music service indicates a reference level of minus 7 LUFS, 7 dB louder than the video platform. This indicates that the chosen loudness targets are rather arbitrary, even for YouTube. But minus 14 LUFS, or maybe even minus 16 LUFS, appear to be where things are heading at this time. What's the takeaway? You can master your audio to be louder than YouTube's reference level. Many videos indeed exceed the minus 14 LUFS limit. But on the YouTube video platform, doing so may be pointless because YouTube will reduce the volume using its volume normalization protocol. There may be other reasons to master louder, but trying to achieve a louder YouTube video playback volume is not one of them. Thanks for watching.